Hello, my name is Richard Irwin, Marketing Manager for Operational Analytics Solution for Bentley Systems, and welcome to this presentation. Today, I'll be talking about how, despite a continued downturn in the oil and gas industry, there are still opportunities out there and available, provided by Bentley, that will allow operators to succeed in these troubled times. During this presentation, we'll look at some of the innovations and technologies that can be implemented to turn around fortunes, from asset performance solutions to drone inspections, and determine that challenges to costs, performance and safety can be successfully addressed. The oil and gas industry has always strived to improve business and production by reducing costs, improving performance and eliminating risk. Operators are used to going through bad spells that go along with the boom and bust era, knowing that they will come out again at the other end. But the latest downturn in the industry has made these core actions even more important than ever. The last few years have been rough for the oil and gas community, hit by a series of blows with serious consequences. With declining oil production, a dramatic cutback in spending, and plummeting oil prices, especially after record highs not so long ago, things appear bleak. Since 2014, oil prices have been on the slide downwards. The consequences of such oil price fluctuations on the world economy are many, but they are hard to pin down as they vary across countries. But common factors include the closure of rigs that aren't productive or are making a loss. This results in the shedding of jobs, salary cuts, higher prices at the pumps, even global destabilization and more. Operators that have survived the crisis face two main challenges. The first is, how do they manage their survival through the downturn? Do they just simply wait it out? The second is being faced with uncertainty for the future, where making long-term planning financial investment decisions become harder to make. Things look bleak. But it doesn't have to be all doom and gloom. There are still technologies and applications available that allow producers to innovate and become agile and forward-looking, even in tough times. Instead of waiting for oil prices to recover to start spending, some oil and gas CIOs and COOs are working together to take advantage of digital advancements to help them achieve operational excellence. They don't have to wait for a significant increase in oil prices to start increasing exploration and production to achieve profitability. Companies like Bentley Systems and their AssetWise services, with the expertise and domain knowledge in the oil and gas industry for many years, have a variety of solutions to help operators recover and achieve operational and maintenance excellence in existing infrastructure operations. This provides improved reliability and performance, reduced risk, increased safety standards, and overall increased operational efficiency and effectiveness. Key to starting a change in fortune is being proactive and using what you have got while investing in areas to help towards a digital transformation. Data and information are at the heart of this, and using the data to its maximum potential. Data is abundant in asset-intensive industries like oil and gas, especially with sensors, the Internet of Things, and big data. There is a need to bring in other data sources, such as 3D engineering models and engineering data, and combine it with standard data from operations and IT, and use sophisticated analysis techniques like advanced analytics, machine learning, and neural networks. Combining digital data sources removes the barriers of traditional business platforms and practices, and by adopting new technologies will lead to productivity, agility, and innovation. Ideally, in any business, efficiency and performance can only be improved if everyone works together. But this is sometimes harder in practice than it first seems. In the oil and gas industry, it would be ideal if exploration were in touch with what's happening in production, if production were working with operations, if operations were synchronizing with the inspection teams, and so on. In other words, a seamless connected environment used to manage the different business functions and pinpoint inefficiencies. For instance, take Emerson Process Management, a supplier of products, services, and solutions that improve process-related operations across many industries. They created a data control center that brought together groups from disparate departments across multiple locations to one central hub using state-of-the-art technologies around communications, conferencing, analytics, and more. The Integrated Operations Center is called IOPS and leverages Bentley's AssetWise operational analytics application. The IOPS Center helps clients simulate business conditions and make decisions in a matter of minutes rather than days and weeks. The predictive operational analytics software on the connected servers provides the center's clients with an array of readily mapped inputs within user-driven dashboards for full visibility. With the Internet of Things, adding more to a world already overloaded with data, asset-intensive industries are quickly jumping on board and embracing this revolution. With so much data lying around, the problem is how to capture it and use it to your advantage. Applications such as Bentley's AssetWise are front and center because of their ability to process and gain control of larger datasets. These applications give user groups an ability to see a holistic view of the day-to-day running of the operation, from production, performance, against targets, KPIs, chemical usage and spend, corrosion levels, maintenance plans, inventory, and more, even 3D models. It also gives the operational or integrity management leader information and support they need to make the right decision. More important is that engineers can do the analysis, input, and configuration themselves, without the need for specialized data analysts. This saves time on data manipulation, configuration, analysis, and reporting, as they can all be done quickly and easily by the user, from a wellhead engineer to a CFO, so they can create their own specific dashboards tailored to what they want to see within their role, wherever they are, in the field or in the office. The embedded analytics will do the job for them in the background, so they can focus on what's happening around them and make decisions based on the information they receive. Although spending in the oil and gas community has been drastically reduced, operational cost reduction and eliminating risk are still top of any CIO's list. Now the focus is on the remaining assets and optimizing them to gain the best performance, reduce failures, and maintain availability. Key to this is reliability and maintenance to extend the life of aging assets safely and reliably. Having a program in place for inspections, maintenance, integrity, and performance will significantly reduce risks and associated operational costs, while increasing the life of assets that would normally be replaced. Asset reliability and integrity management cover a wide variety of areas, from risk-based inspections, analysis, and safety and integrity management to condition-based monitoring with dynamic measurement points, asset health indexing, and in the same system, reliability-centered maintenance, maintenance task analysis, and root cause analysis. With these strategies in place, it is easier to identify and predict the failure of assets that pose the greatest risk to the operation. Identification leads to controlled and proactive inspection and maintenance practices that are crucial in running an effective and productive environment. Advanced analytics provides more depth to the levels of insight by doing more complex analysis from wider sources of data, as well as visualization and data mining. With the power to predict, it adds an extra level to what would otherwise be unseen, to not only what happened and why, but when will it happen again. For instance, predictions can help with calculating production against chemical costs, the corrosion levels of the pipe in terms of when it will need replacing, and the subsequent maintenance required. The next logical step from this form of logic is prescriptive analytics, not only predicting an outcome, but also what is the best action to take next with the most advantageous outcome. With machine learning, this becomes a reality. Machine learning can be described as a form of artificial intelligence, where the technology uses big data from multiple sources like sensors, mobile data, the Internet of Things, networks, and applications, and through the use of algorithms is able to derive more insight from the data than, say, traditional analytical methods like business intelligence solutions. By using historical condition data from assets like corrosion, vibration, and so on, as well as current conditions such as temperatures, pressures, turbidity, machine learning can sort through large sets of data and identify patterns or connections, predict outcomes based on the knowledge, and make predictions and recommendations to decision makers on the best course of action to take. It is no coincidence that machine learning is becoming more prominent as the industrial Internet of Things gets bigger and bigger. As the velocity and variety of data becomes available through advancements in sensor technology to monitor just about anything and everything, a better way to manage and make sense of increasingly large and fast-moving data sets is the application of machine learning. Machine learning can handle large and complex information to discover otherwise hard-to-see patterns and continuously learns to deliver more accurate insights and forecasts. That is why the Internet of Things and machine learning are made for each other, as they both have what each other needs: the means to produce large amounts of usable data, and the means to use the data and derive more deeper insight from it. Due to the harsh and inhospitable conditions associated within the oil and gas industry, the ability to be able to recognize equipment failure when you consider the consequences is critical to success. With unplanned downtime, the associated costs of repairs and potential damage to the environment and fines involved, failure to maintain assets properly can be the difference between staying competitive and falling behind. This is even more relevant in today's turbulent times. With machine learning, there are numerous opportunities to improve the situation. One of the key uses of machine learning in the oil and gas industry will be predictive maintenance. Predictive maintenance falls under a variety of categories: failure prediction, root cause analysis, failure detections, failure classification, to diagnosis and recommendations of maintenance actions and procedures. In its simplest form, it is a technique that will determine when a machine or piece of equipment will fail, so that maintenance activity can be planned well ahead of time and then carried out more effectively. Machine learning does this through data collection, storage, manipulation and analysis, and combines it with models and algorithms. By monitoring historical and near real-time data, such as sensor values and various other connected parameters, it can calculate with a high level of accuracy asset failures in the future. As well as predictive maintenance, there are many other areas machine learning can help oil and gas companies to save time, costs, and improve safety. One such area is predicting demand from similar cases, or use cases. This is done by using machine learning algorithms to identify similar problems and what actions were taken to solve the issue. Operators can then use the information to analyze data, such as the economic conditions, asset performance, the weather patterns, to forecast demand and production. Because of the benefits they can bring when coupled together, the industrial Internet of Things and machine learning should no longer be considered as just buzzwords or technologies that would be nice to have. Instead, when they are put together and applied together, they should be a number one priority. With so many assets producing so much data around the world, this information can be used to provide more insight into the performance and efficiency of any operation. What is often forgotten is the information on the assets themselves. Asset lifecycle information management provides a structured control of asset information and managed change from cradle to grave, ensuring engineers, maintenance and operations always have accurate information. Knowing what and where assets are located exactly, what condition they are in, how they are performing, and what is their remaining life is critical to knowing you have control over your operation with line of sight. Maintaining a seamless information stream between asset data, documents, organizations, requirements, people and processes, asset lifecycle information management assures information integrity. For example, BP sees asset information becoming crucially important and valuable within the business. So much so that by using Bentley's AssetWise ALM solution, BP expects to provide new understanding of how to derive value from the data. This will help drive standardization and project execution efficiency that will be driven out across the enterprise rather than each project working on their own separately. Another area to look at is drone technology. Manual inspections of oil and gas fields and refineries looking for leaks and damage can often be dangerous and risky for the men and women who carry them out, as well as proving to be often unreliable. The risk to inspectors remains high, as does the cost of any associated shutdowns and production outages. Drones are now starting to play a big part in the inspections process today, as they offer a wide range of benefits regarding cost, efficiency, and agility. They can collect critical data easier and quicker. Instead of performing a time-consuming manual operation, drones can easily perform and analyze cracks and detect corroded pipes and equipment. Instead of expensive and unsafe manual inspections of offshore and onshore oil installations, drones can use the difference in the temperature and soil and fluid to quickly detect oil leaks as well as access dangerous areas. They can also quickly discover source and direction of any spillage and pass on information quickly for immediate action. As well as being used for inspections, drones can also be used for creating digital engineering models of offshore structures, refineries, and more. Using technology such as Bentley's 3D imaging software Context Capture, photographs can be transformed into detailed, comprehensive 3D models of all the infrastructure data, and done in a less labor-intensive, cheaper, and more efficient manner. These reality modeling solutions can then link inspectors in the field to engineers in the office, sharing information and data seamlessly. With continuous modeling of a site or an installation, it means personnel can survey the asset throughout its life cycle, from initial design to current condition, applying the difference in data to maintain up-to-date data on the equipment's condition along the way. Continuously up-to-date reality becomes the context within which oil and gas operators can design, build, and operate their infrastructure projects. These models can also be embedded into dashboards within AssetWise. What we've shown here during the course of this presentation is that investment into asset, operational, and engineering technologies will bring a variety of rewards and benefits. This includes using dashboards in the projects world, which provides total visibility and actionable insight across all areas of the operation, which gives the ability to view, interact, report, and share information on any aspect of the asset or operation, giving you complete overall performance. Then there's the visualization and prediction for the management of assets. Today, organizations are already able to begin to both visualize and predict outcomes. Users are able to monitor asset performance in real time. They can also combine additional information sources, such as weather forecasts and IT information, and then ultimately, with algorithmic-based calculations, they can perform future predictions, such as demand or forecasting production, even failures. All of this users can do today. But what about the more complicated predictions, which requires more data? With machine learning, deeper and more insightful analysis will be able to reproduce known patterns in knowledge, automatically apply it to other new data, and then automatically apply these results to decision-making and actions. Machine learning features complex algorithms to sort through large amounts of data, identify patterns and trends, make predictions, and prescribe courses of actions. Engineers and key decision-makers need to take advantage of advances in machine learning and the data available from the industrial Internet of Things to optimally control and manage their assets and operational data. Preventing assets from failing, forecasting demand, and optimizing movements of the workforce are just a few of the machine learning techniques that can be applied to improve the overall performance of the organization. Digital engineering models unites real-time dashboards and analytics in the complex plant world by being able to access information from your 3D model in near to real time. This is what's commonly called as a digital twin, where a physical object has its own digital representation. Whereas 3D models have been traditionally used to design assets, they can now be used to represent the asset throughout its life cycle, so that everything that happens to the physical asset throughout its life is replicated digitally. Everything that can be achieved at the physical location, from reading data to inspections, can be done so remotely and accurately from a computer. The digital transformation is already here, and Bentley is bringing forward technologies that help our users make better decisions by bringing together a selection of linked disciplines under a connected data environment to ensure all your assets are looked after and the whole organization is in complete alignment. In summary then, the oil and gas industry doesn't need to wait for change to happen. They can take advantage of technology that is not coming soon to an oil field near you, but is already available right now. What we've seen here is some of the innovations in the oil and gas industry that enable leaders to create opportunities during an industrial downturn. Advances in analytics, generated data, and hardware can lead to significant advantages across all areas of the oil and gas spectrum, when it comes to leading the digital innovation charge, culminating in the digital oil field. The digital oil field can then deliver the promise of reduced asset downtime and maintenance costs while providing production and performance.